Hi everyone, I'm the Journal Modeling Prof. Today we'll crack the 3 hardest parts of a PhD thesis all at once. A lot of people don't realize until year 3, what really blocks graduation isn't writing, is that you can't build the model, can't analyze the data, and freeze at the defense. China admits 150,000 PhD students a year, has 610,000 enrolled, yet only 87,000 graduate a year. Delayed graduation is the norm, it's not just you. The path has 3 gates: how to build the model, how to analyze the data, how to pass the defense. Today, we walk through all 3. Gate 1. Building the model. But before any model, is your topic a real question? A master's proves you can do research, apply no methods well. A PhD proves you made research no one else did. Totally different game. The biggest trap, thinking nobody's done it means it's novel. Often nobody's done it because it's not worth doing. A real gap clears 3 bars at once. The literature truly lacks it, filling it matters, and your data can actually answer it. Miss one, and it's a fake question. A good gap is the missing piece in a nearly finished puzzle. Fill it and the whole picture is complete. Not some stray scrap nobody bothers to pick up. Remember, find that real gap first, and the model finally has somewhere to stand. With the real question, step 2, the model isn't plugged in, it's derived. One logic chain, anchor a theory, derive directional hypotheses from the mechanism, then land a model that can be estimated and falsified. Reviewers love to ask, this interaction term, which section is its theoretical basis? A variable with no theory behind it is data mining, and the defense will punish it. Don't ask which fancy model to use, ask which problem you're solving. Measurement error needs SEM, nasty data needs multi-level models. Dynamic endogeneity needs system, GMM. Methods are for diagnosis, not for showing off. A fancy model means nothing. Reviewers only care what it solves. What really sinks you usually isn't a model that's not complex enough. It's specification error. Drop one variable you should have kept, and your whole conclusion can be wrongly accused. In one line, the model grows out of theory, and every line traces back to a source. Step 3, and the defense's killer question. Your coefficient is significant, then your advisor asks, is this correlation or causation? And you're stuck. Correlation can become causation because of endogeneity. 4 sources, omitted variables, reverse causality, measurement error, sample selection. First, judge which one you've got. What's an instrumental variable? One line. Find a switch that flips X but never directly touches Y. Like using distance to the nearest college to pry open education's effect on income. Diff rests on parallel trends. Before the policy fires the starting gun, treatment and control must run side by side. Only the gaps that opens after counts as the policy's effect. Here's the big trap. After 2021, for staggered DID with different treatment timings, plain two-way fixed effects can flip the sign. Reviewers kill it on sight. And first stage F/10, instruments fine. Seeing that now loses you points. The real threshold was pushed up to 104.7. Remember, reviewers don't care which method you used. They care whether you can explain why this design identifies causation. Make the identification assumption airtight, and your whole empirical section stands. Gate 2, Data Analysis. Chapter 4 isn't running one regression and printing a table. It's a complete chain of evidence. 6 standard moves. Clean, describe, baseline regression, robustness, heterogeneity, mechanism. Break any link and one reviewer question topples you. Continuous variables get Windsorized first. Trim the nails, don't cut the hand. One line, Windsor 2, cuts 1 and 99, and a few extreme values won't drag your coefficients off course. Baseline regression in one line, REGHDFE, absorb ID and year, soaking up firm differences and macro shocks. That's the chassis of panel data. Standard errors must be clustered. People in the same group huddle together. Without clustering, you'll call non-significant results significant, a top reason for rejection. Mechanism testing has changed. After Jiang Ting's 2022 paper, if you're still running the old 3-step method, reviewers instantly know your method is dated. Weld every link of this evidence chain, and Chapter 4 can take the hits. So how do you actually read the table? One regression table. Look at 4 things at minimum. First, direction. Is the coefficient positive or negative, and does it match your hypothesis? If the sign's flipped, don't rush to write. Go check the specification. Second, significance, 3 stars, 2 stars, 1 star. But don't just stare at stars. The standard error in parentheses is what backs it up. Third, coefficient size, the economic meaning. Move x by 1 standard deviation, how much does y change? Significant but tiny still means nothing. Fourth, explanatory power, r squared, the f stat, and the sample size n, not one can be missing. That's the basic honesty. Direction, significance, size, explanatory power. Get all 4 and you've truly read the table. A significant baseline is just the appetizer. What really sets you apart is these 3 gates. Is it reliable? Who is it useful for? And why does it happen? Robustness isn't about piling up checks. It's about sealing off every, well, maybe it's because, in the reviewer's mouth, one by one. Swap the measure, swap the sample, swap the model, throw in a placebo test. If the conclusion holds across every way of living, then you've earned the right to say, I found a pattern. Heterogeneity answers, who does it work better for? But the grouping needs a theoretical basis. Don't slice the sample every which way just to get significance. And one group significant, one not, does not mean there's a difference. You must run a between-group coefficient test, or one reviewer question silences you. For mechanism, stop with the stepwise method. Just bootstrap the indirect effect and see if the confidence interval excludes 0. That's the mainstream approach now. Pass these 3 gates, and you are finding upgrades from it wrongs to it's credible. When reviewers open your thesis, they don't read the words first. They look at your tables and figures. An ugly table drops your professionalism 3 notches. Stop submitting raw SPSS or Stata screenshots. A screenshot is like writing, I'm still a beginner, right into your thesis. The 3-line table is academia's formal dress. Only a top rule, a header rule, a bottom rule. No vertical lines, no grid. Coefficient, SE in parentheses, stars, N, R squared, not one missing. You don't need to count stars to see significance. On a coefficient plot, if the whisker touches 0, it's non-significant. If it doesn't, it's significant. Read the table in 3 seconds. Running DID without an event study plot is basically going naked. And after 2021, the plot the old method draws might be entirely wrong. Get your tables and figures to journal grade, and your thesis wins half the impression battle up front. Gate 3, the defense. The first thing they pursue is always, what exactly is your contribution? Remember, contribution isn't how much work you did. 1,000 questionnaires, 50 regressions. That is workload, not contribution. Contribution has 3 tiers. Theoretical is highest, methodological next, empirical or contextual third. A PhD needn't force a theoretical one. Just make it clear and make it real. But swapping US data for Chinese data, last year's sample for this year's, and calling it novel? To reviewers, that's the same dish served on a different plate. Real novelty has a universal template. Prior work did X but missed Y, and I filled in Z. Whose shoulders you stand on, which seam you closed, say it in 1 line. And go easy on first ever and fills a gap. Professionals always leave themselves a little room. Finally, the defense itself. First, remember one thing, a defense isn't a debate. Your goal is to pass, not to win. A defense is like inviting the committee home to tour the house you built with your own hands. Argue them into silence and you've actually lost. The committee circles the same 7 or 8 questions. Contribution, endogeneity. Why this method? Is the sample enough? Are the results reliable? How it differs from whose work? Policy implications. Highly predictable. Memorize one universal formula and any sharp question stays steady. First, think and acknowledge. Then answer with evidence. Finally, give a direction. 3 steps. Test it and it works. Asked about endogeneity. Just saying I used the instrument gets you exposed. The next line is, what's your first stage F? Why is it exogenous? Can't answer and you're caught. Nervousness is normal. Dunning-Kruger. The more you know, the less you think you know. Feeling nervous actually means you really understood it. Model grown from theory. Data welded into a chain of evidence. Defense argued airtight. Pass these 3 gates and you graduate. I'm the Journal Modeling Prof. See you next time. If this helped, hit follow.